First off, I'm just going to go over creating a new file and environment. So go ahead and after you've created a project, which should prompt you just opening it for the first time, you just go to New again, Python file, type whatever you want. I know I went over this a little bit in the last video, but I thought I'd make it a little bit more obvious. And then as soon as you go ahead and make your file, go ahead and create your new configuration, because each configuration is just set up to run a single file. And you can just keep reusing the same file, comment out old code or whatnot. But for my purposes, I like having separate files for the different things. So I just copied the existing test setup, and then I'm just going to change this over to the new file I made, and apply, OK. And now I'm all set up to run my new file. So these are the things we're going to be going over today. Very briefly, at the end of the last video, I mentioned how to capture user input, and that opens up kind of some additional things you need to keep in mind. So for example, if we're going to ask somebody to give me a number and store that as X, all user input is brought in as a string. So again, going back to the basic data type, string can be anything. It just has quotations around it. And so if we print off that type, I'll just go ahead and do that. Give me a number, say 1. I'll try that. Sorry, probably shouldn't have put a space there. Go ahead and print it out. So print type X, put 1, and it's a string. But maybe we are going to do some mathematical, do some math on this value that we're getting from them, and so we need it as an integer so that we can properly, multiply it, divide it, whatnot. Python has a built-in function for you called int, which just turns a string into an integer. So we'll say int x is equal to that, and then if we print type x, that should print integer. Yeah, oh, yeah, there we go. There we go. So at first it's a string and then it's changed to an int. Also just a little side, not as important, because I find it annoying to just type the input right after like that. So what you can do is you can tell it to print out a new line by doing \n. So this is just a magic thing in like all coding that represents give me a new line. So if you hit enter now, when I go to type in, it's not up here, it's down here. And so it works the same way. However, user input by definition is probably always going to not be what you want. So suddenly if I type in something that's not a number, I'm going to get an error, a value error, because it tried to do this function and it was expecting something that could be turned into an integer, but it wasn't. So this is where try except comes into play. Try except is just when you're going to do something that you know might throw an error and you want to do something in that case. So in this instance, it's this trying to turn it into an integer that is giving us trouble. So we're going to throw that into a try section. then we have an accept section. So the accept section, the try section will be run essentially no matter what, and the accept section will only be called if there was an error that came up during this try block. Alright. So if we run this, like, let's see. So this, it tries it, throws an error, it runs the accept, and then it keeps going on with our code because it tried to print out type of int x, but int x is no longer valid. So that's one value. If you don't want your entire program to just stop when it hits an error, you need to use a try except. So make that a little bit cleaner. Yeah. So again, you see it keeps going. And if we give it a valid number, it never prints try again. So again, this accept only gets called if there's an error raised. So anytime that you're working with user input, you're probably going to want to have a try except just to ensure that your code works how it should based on any input that they could give it. And whether, working as it should is failing or prompting them to give you new input. So next up is a more complicated data type, a dictionary. So this is probably one of the more useful data types. A dictionary is created using curly braces, and what it serves as is like if you think about an actual dictionary, you have words and then they have definitions, and each word is unique and it can have any value or any definition associated with that word. And so Python dictionaries are the same. You have a unique key set, and each key corresponds to some value. So we'll say first key equals first value. Yeah. However, so these have to be unique, kind of like variables are unique. So if I assign a different value to this key, it's going to overwrite that value. So first value is no longer there. Dictionaries can hold an arbitrary number of keys, and the reason that they're useful is because it's very fast to find a value in a dictionary as long as you know what its key is. So, I mean, you can see that it's instantaneous essentially for printing off these values. It will be as instantaneous if this dictionary contained 1,000,000 entries. So it's just by virtue of its keys being unique, it's incredibly fast to access values in it. Much like a list, the values don't have to be of the same type. They can be any other data type as well. So we can make this into a list, for example. There we go. Yeah. And the value can even be a dictionary of its own. So when you come across a use case for a dictionary, it is super useful. Until then, it's just kind of an abstract concept, but just take my word for it, they are incredibly valuable. Next up is debugging. So debugging is a nice way to figure out what exactly is going on with your code, especially when you start making more complicated projects. So I'll just actually uncomment this section. And this is why PyCharm is helpful in particular, pretty much. So PyCharm is an IDE, or integrated development environment. Essentially, it gives you everything you need to code effectively, but there's no difference between this Python file and just opening up, any text editor, writing out your Python code, and then saving it as a Python file and just running it. Python just works as long as you have it installed and you write your code correctly. But a text editor doesn't have, debugging doesn't have built-in, input-output console stuff. So I think debugging in particular is the most useful aspect of using an integrated development environment. So I'll show you. Essentially, what you choose is, say, you just choose an arbitrary line, and you click in this margin here, and it's going to put a red dot there. And then instead of hitting the play button, you hit the debug button. And so what that does is it runs your code up until the point or the line that you've put the red dot at, and then it pauses it there. And it's nice because you can examine exactly the state of your code at that point. So for example, it pauses here before running this line. And so we can see down here in our variables, you've got your dictionary, and it's got first key equal to second value, because that's how the dictionary is right at that moment. Also relevant in more complicated things, if you have code that's calling a couple of different functions, it's going to show over here everything that happened, essentially what lines got called before being at where you're stopped. And that probably will make more sense later. So when you're debugging, you can have multiple breakpoints, are what these are called. You can skip to the next one by hitting the play button. At one, you can there's step over and step into buttons. So step over just goes to the next line. Step into if this line is calling, this line is calling the print function. Step into would, if print was something we defined, it would step into that print function and execute the next line there. So I'll give an example of that here. I'll just say print stuff. Similar to the string function, just takes an integer or whatever and turns it into a string if it can. So let's do that. Call print stuff down here. And debug. Alright. So step over, and then actually let me make this more clear. rerun this. So step over will skip over print stuff and just go to your next actual line of code that you've written in this section. So it doesn't go into functions, it skips them in the sense that you don't stop at this line. Like this still happens no matter what. So if you go to your console, like it printed out test 3. Stepping into though will move up to the line and it'll show you the scope of this function. So click next. Okay, suddenly we have this variable x. Step over, suddenly we have the variable y. And then stepping over returns to where this function was called and goes, and then so that's where it was called, and then it goes on, which is nothing because it's all commented down. So yeah, debugging is super useful for if your code isn't working how you think it should. Just seeing the exact state of your code at any given time, yeah, it's very helpful. And one final thing about the debugger as well is that at any point you can also click this little calculator icon, and it lets you interact with your code even further just by typing further Python or whatnot. So like, yeah, dictionary third key or whatever, and it'll give you back, oh, this is what we have under dictionary third key, so that's this array. So what you type here isn't necessarily part of your code, but it is a way, again, another way to interact with your code. And it might actually let you change it. Yeah, so you can impact the state of this. So I just overwrote the value of third key, and so now if you step over, it's going to print 1 instead of what was originally there. So you can, test, make sure, like, oh, maybe my code should be, maybe I'm sending it the wrong type of input. Let's try changing it there. It's, yeah, just a faster way than running your entire code again. So that is debugging. A lot of time coding is spent figuring out what is going wrong, and debugging definitely helps. Okay, so last thing I want to go over is our libraries. So essentially, I mean, anything you want to write, you can just create yourself. But a lot of times, especially for complex functionality, people have already created code to do what you want, and then they publish it to the interwebs as a Python library. So for example, with like Python essentially has its built-in library, which is where this print function comes from, or the int function or string function. There's a random function for generating random numbers. So to bring in a library into your code so you have access to its functions, you just look up what it is and then you import it with its name. And so now I've got access to randoms functions. So for example, random has, okay, create a random integer between 1 and 6. And I can just run that a couple of times. 4, 4, 3, 1. Okay, I guess it really likes 4. And that's a lot simpler than figuring out a way to generate a random number on your own. But if you machine learning, artificial intelligence, image recognition, like there are libraries for these things, and take advantage of code that other people have made. It takes a little while getting used to having to look at descriptions of what their code does and how you interact with it, but it's a lot less time than making stuff yourself if you can reuse what other people have done. So I I want to show you. So this is something that I'm working on for my brother, and as you can see, I'm using a lot of different libraries. So for example, I'm using this Selenium library, which allows me to, open up a web browser essentially and interact with it. This datetime library, which gives me a new, class essentially and a way to interact with it, allowing me to store a date time like, today's, 7/24/2019, 12:18 p.m. Like that is a date with a time, and Python doesn't have that built in. I've got these decimals, so instead of integers, I'm using decimal numbers as well. This Pi ODBC, which helps me connect to a database. And so like this code of mine that goes to healthcare.gov and grabs some information relies heavily on libraries. So you can do some amazing stuff if you figure out how to use libraries. But it's different for everyone. You just have to do a little research on how to effectively use them.